Hi, this is Adrian from Live to Learn Academy, and today we're going to be going over lesson 6.3, exploring graphs of the primary trigonometric functions. If you're somebody who needs tutoring, feel free to click the link in our description below. It'll take you to our tutoring service where we offer tutoring for all students in the Ontario curriculum. But without further ado, let's get straight into it. So guys, the first thing that we need to know are what are the primary trigonomic ratios? Okay, so primary trig ratios. So what are these primary trig ratios? We have sine x, we have cos x, and we have tan x. Now, with each of these primary trigonomic ratios, they have certain graphs that are associated with the ratio. So we need to understand how these graphs look like. And from understanding these graphs, we're going to understand them in terms of radians. So remember, in grade 11, you did these same graphs in terms of degrees, but in grade 12, you're going to do these graphs in terms of radians. So let's look at the sine x graph first. So the sine x graph looks like this. And you might want to write these graphs down as it'll give you a good indication of how these graphs are going to look like. And it's good to memorize these graphs. So remember, we're putting these in radians. So if you notice, I used pi over 2, pi, 3 pi over 2, and 2 pi. This represents 90 degrees, 180 degrees, 270 degrees, and 360 degrees. And the graph looks like this. There are 5 key points. 3 that are on the axis, and then 1 up here, and 1 down here. And if we actually draw this graph out and connect the dots, it would look something like this. So this is pretty straightforward. This is the sine x graph. Now, there's a couple key things we want to know when it comes to these graphs. Some of them key terms. So here are some key terms that we want to know. The first thing is we want to know what the amplitude is. Okay? The second thing is the axis of symmetry. The third thing is the domain. The fourth thing is the range. And then the fifth thing, we got the max. And then the last thing is we got the min. And there's another one as well, and I'm going to add that in here, which is the period. So these are key terms that we need to know for each of these graphs. So right now what we're going to do is we're going to go over the sine graph specifically, and we're going to find out all 7 of these key terms. Once we do that, we're going to do the same thing for the cos graph, and then the same thing from the tan graph. And these are things that you're going to want to memorize and understand because a lot of your chapter 6 is going to revolve around these primary trig ratios. So the first thing, let's define it. What actually is the amplitude? When you look at a graph, an amplitude is basically the distance between the max and the axis of symmetry, or the distance between the min and the axis of symmetry. So this is called the amplitude. Right? And because it's symmetrical, we know that the amplitude from the axis of symmetry to the max will be the same as the amplitude from the axis of symmetry to the min. That brings us to the next point. What are the min and maxes? So obviously we know that is the max, and we know this is the min. Cool. Okay, domain and range is pretty straightforward. We learned that in grade 11 and with all the other functions. Domain is how far in the x direction we go. Range is how far in the y direction we go. So what is our axis of symmetry? Our axis of symmetry is kind of like our midline. So you can think of it as this red line that I'm drawing here, this dotted red line. This is our axis of symmetry. And our axis of symmetry holds the equation y equals 0. Because as you can tell, it's a horizontal line, so it's going to be y equals, and it's 0 because it's directly on, that x-axis, which is 0. So our axis of symmetry is that midline of the graph. So we got our amplitude, our axis of symmetry, our domain, range, our max, min. Now, the last thing we need to know is our period. Our period is how long a cycle is. So this is the period. And the period is the length of one cycle. Okay? So as you know, these graphs, these sine graphs, they'll repeat on and on and on and on and on. I just drew one cycle of it. So the notion of what a period is it's the length of one cycle. right? Just like how you have like classroom periods when it comes to school, it's the length of one class. In the same way, this is the length of one cycle. Or if you use like a hockey analogy, right? A hockey game has 3 periods that are 20 minutes each. What is the length of one period, right? So 1 period is the length of one cycle when it comes to sinusoidal functions. So if we look at this, these are the definitions. Now let's actually fill out this the key terms to actually demonstrate what it is. Now, the amplitude and the axis of symmetry, there's a key thing that I want to let you guys know in on. The amplitude, there's another way mathematically that we can actually find the amplitude. And we can use this equation. Amplitude is equal to the max minus the min divided by 2. So if you actually look at what is the max is 1. What is the min? The min is -1. Divided by 2, we end up with 2 over 2, which is 1. And that's our amplitude. So sometimes using the formula, like amplitude, you can get it in 2 different ways. The first way, you can look at the graph and actually just see, okay, that's my amplitude. Or 2, if you're only given the max and min in the question, you can use this formula to get at what the amplitude is. In the same way, axis of symmetry, we can look at the graph and say, okay, yeah, the axis of symmetry is at y equals 0. But if we didn't have the graph, the way we can get the axis of symmetry is by doing max plus min over 2. So that would be 1 plus -1 over 2, which is 0 over 2, which is 0. So that's your amplitude, that's your axis of symmetry. Now, your domain is going to be theta is an element of the real, where theta is all real numbers. So it's kind of like saying x is an element of the real, but we're saying theta is an element of the real because these numbers are actually all angles, right? Because we're dealing with this in radians, right? So it will be theta is an element of the real. But the range we're going to do in terms of y. So y is an element of the real where y is between -1 and 1. Because the highest it goes is 1, the lowest it goes is -1. So everything in between that is where the graph exists. The max we already know, the min we already know, and the period. The period is the next thing we want to know. So all we got to do is we got to look at our graph and see how long is one cycle. So as you can tell from the graph, one cycle is 2 pi in length. Now, when you're given equations, now for this particular question, I gave you guys a graph. Sometimes they'll give you an equation and we'll go into this when we get to the next unit in transformations. But another way to find period is by doing 2 pi over the k value. Okay? So this is a formula that we can use for period down the line. Cool. So we got all our key terms. We understand how to do the sine x graph. Now let's do the same thing, but let's do it for the cos x graph now. So how does cos x look like? Cos x is very similar to sine x, but instead we have pi over 2. So these 5 points still remain the same. This is 1, this is -1, but instead we start up here. So we start up here, and these are the 5 points that we go through, right? It kind of looks like the sine, but it's shifted pi over 2 to the right. So this is something to know. It's just the sine x graph. So the cos graph is literally just the sine x graph shifted pi over 2 to the right. Okay? Shifted pi over 2 to the right. Now that we know that it's shifted pi over 2 to the right, let's find out what our key terms are. So I'm actually going to take this guy. Actually, I'll just write it down here. You have your key terms. So the first thing you're going to need is the amplitude, which we can just look at the graph and find it. We know it's 1. We also know the axis of symmetry is going to be y equals 0. We know the domain and range are very much the same as the sine graph. So the domain is all real numbers. The range is y is an element of the real, where it's between 1 and -1. You have the max, which is at 1, which is very similar to the sine graph. And you have the min, which is at -1, which is also very similar to the sine graph. And the last thing is the period, which is 2 pi, which is also very similar to the sine graph. So as you can tell, the cos graph is very, very similar to the sine graph because they work together. The sine and cos, they're like brother and sister. You could think of it like that. So you have your max, you have your min, you have your amplitude, right? You also have your period, which is the length of one cycle. And then you also have your axis of symmetry at y = 0. So hopefully this is making some sense to you guys and you guys are kind of understanding it. But the one thing that is a little bit different from the sine graph and the cos graph is the tan graph. So you can think of the sine graph and the cos graph as brother and sister, but you could think of the tan graph as like a cousin of the sine graph and the cos graph. So let's quickly take a look at what that tan graph looks like. The tan graph is a little bit different. The tan graph has asymptotes. Okay, the tan graph has asymptotes. It has an asymptote at pi/2 and -pi/2, and then another asymptote at -3 pi/2 and 3 pi/2. So if we draw these asymptotes in, you'll have it looking like this. So remember, an asymptote is where the graph will never touch these points. Okay? And how the sine graph looks is within these asymptotes, or these like jail bars, you can think of them as jail bars, you're going to have a function that looks like this. It's going to be like a swiveled function. So that's going to happen like that. And it's just a repeating pattern of these swiveled functions. Now, obviously the middle one, it starts at 0, but the one on the right will start at pi and the one at the left will start at -pi. So now it's a little bit different in terms of finding our key terms. So if we look at our key terms for the tan graph, we know that we have amplitude, axis of symmetry, we have the vertical asymptotes, so that's going to be a key term of the tan graph specifically. We have the domain, we have the range, we have the max, we have the min, and we have the period. So the only extra thing we need to know is the vertical asymptote when it comes to the tan graph. Now here's the thing, the amplitude, it's actually undefined because this graph goes forever and ever up and forever and ever down. So we actually don't know what the amplitude is. So in the tan graph, we know the amplitude is undefined. The axis of symmetry is at y = 0. So the axis of symmetry will still be at y = 0 because everything is flipped along this line. This is kind of the midpoint, which is the axis of symmetry. The vertical asymptotes we know are positive and negative pi/2, and then positive and negative 3 pi/2. And you can imagine these vertical asymptotes, what's the distance between these two vertical asymptotes? The distance is pi, because 3 pi/2 minus pi/2 gives us pi. So the distance between the asymptotes is pi, which means that we can do this pattern by just if we keep on adding pi, we'll find the other vertical asymptotes as we continue along going forward to the right. So this actually ties in pretty nicely to our domain and range. Our domain is going to be theta is an element of the real, where theta does not equal pi/2 plus minus, and then plus minus 3 pi/2, and then plus minus, let's see, the next one would be 5 pi/2. So remember, the domain is, it exists everywhere except these points, right? Because obviously this ties into the vertical asymptotes. The range, however, is a little bit different. The range is y is an element of the real, right? And it exists in all real numbers because remember, we go fully up and fully down. So because we're going as high as we can and as low as we can, the range really touches on literally every point in the y direction as we extend those graphs. And then when we talk about the max and min, right, these don't exist because it goes on forever, right? So max and mins don't exist. Amplitude is undefined, right? The range goes all the way up and all the way down. So the question then becomes, what is the period? The period is the length of one cycle. Remember, the period, the definition of period is the length of one cycle. So what is the length of one cycle? It's actually pi. If we look over here, the length of one cycle is the same as the distance between the different asymptotes. So the length of one cycle in this case is pi. So there you have it, guys. You know, the tan x graph, the cos x graph, and the sin x graph with the key terms. These are your primary trig ratios. If you are, struggling with this particular unit in trigonometry in school and you need tutoring, feel free to follow along with these videos. I post these videos as a means to help you guys understand the concepts. If you need tutoring, take a look at the description. It'll take you to our website. Fill out the form. We'd love to get in touch with you guys to help you guys out. And if you found this video helpful, subscribe, drop a like on the channel, drop a comment if you have any questions, and feel free to share it to your friends and family, those who are taking the course. But without further ado, guys, I'll see you guys in the next video.